Dr. Virendra Gupta is currently head and research and development on polymer, and also is senior vice president of Reliance Industries Limited, and head office based in Mumbai. And before joining Reliance Industries Limited, he also worked at the Indian Petrochemical Corporation. He did PhD in chemistry from Banaras Hindu University and also work at University of Alabama, USA. And we are fortunate because you are sitting with extensive experience, almost 40 years on different field, particularly organic, inorganic polymers, carbon dioxide fixation, and catalysis and product development technology. So we are very excited to hear some of your experience on these topics. And it is amazing that he's inventor and co-inventor of 150 patents and commercialized close to 25 technologies in polyolefin and polysulfones based products and processes, and also published 70 close to 70 research articles in various journal, and close to 75 invited invited and plenary speaker in different international and national conferences. And one of the greatest achievement, particularly Dr. Gupta, and I must mention, is the researcher first introduced, high performance Ziegler-Natta catalyst for the production of polyolefin, and that is a big business of Reliance where he is now. And he's recipient of number of awards, and one of them is a Vasbik Award and also a PCI Research Award. So again, thank you for your time. So what we are going to discuss, topic, polymer-based advanced functional materials for growth sector, and what kind of challenges we are facing now, and what we expect in future. And as a researcher in this field for a long time, we are very excited to know your views. So my first, you can say, the questions to you that and all of us know that last 20 to 30 years, plastic already transform our lives in all aspect. Okay, and we believe that still is going to transform and impact on our lives. So what you are thinking, what are the futures of plastics going forward?
Let me start, Amit. The growth of plastic in the past is more for replacing the metals and other alternative materials. However, what we look in the future, the plastic will be the solution provider. So the real change which is going to happen in plastic as a replacement for a metal to the solution provider to the society. And this will be a big change in future, which will transform the whole thought process of plastic uses, manufacturing, as well as the sustainability aspect. And the reason, let me elaborate why I want to say plastic will be a solution provider for the society. If I take the example, which is a current healthcare, and this viral infection, which has really affected the economy of most of the countries and also the society at large. Today, everyone is looking the plastic as a solution provider to prevent infection. And that has, you look at, totally transformed in last 6 months the image of plastic, which earlier were more considered as a problem to the society. So this is one example. The moment the plastic has become a solution provider, it has changed the mindset of the society, and it is giving the solutions for the health cares. This is one very recent example which I cited as a solution provider. The second example, which I believe in today's time also and the past also, the food. A lot of food get wasted during the transportations and other. And today the plastic packaging providing the solution to increase the life of the food, and which will allow the food can be its vegetable, fruits and other accessible to all at different period of time. So packaging materials have become also the solution provider for the society. The third example which I give, you look at the water. Water is going to be a very, very valuable and real asset for the society. The membranes technology which have come has started providing solution for purifications of the water, which is a very, very critical for the human beings as well as the animal kingdom also, the water. So these are the three examples. There are many examples which I cite to showcase that what was a thought earlier was the replacement of something is today is considered as a solution provider, and that will really bring a change in the mindset, and that will lead to also a significant growth in coming future of the plastics. The second point which I want to emphasize, in addition to the solution provider, these materials will also allow us to create different functionality in the materials. The recent case is that can plastic may come as a material of choice for antiviral properties, antibacterial properties. Today, a lot of solutions are coming through nano materials in corporations in the matrix of the polymer. But the way the science is growing, there is a possibility that we can have the antiviral functional moiety within the backbone of the polymer, so that it is much more easier for transforming or converting into the products, rather than you use a mixture of inorganic and organic material to make the products. Another example which I look at, the car industries or automobile sector. Fuel consumption is very high because of the very, they are very heavy material steel. And fuel efficiency can be enhanced by replacing the metal with the lightweight material. And here I see composites will be the solution provider to reduce the consumption of oil, and which will also affect the climate factor with the carbon dioxides and other gases evolutions which are coming it out. So indirectly, the polymer composite in automobile sectors or aerospace sectors and other which lead to the lightweight material will give a clean environment to the society. And these factors has really forecasted that in next 2-3 decades, the polymer demand will increase significantly. And I was just trying to see how the growth is taking place. And I saw the data 1950, the polymer demand was just 5 million ton per annum. And today, it has reached close to 350 million ton. So this means, I mean, in just 70 years, from 5 million to 350 million ton. And what different projections are there? But one of the projections indicate that by 2050, the day we will complete around 100 years from 5 million ton, it will be close to 1,100 million ton productions or demand of the plastic material. So this means in 100 years, it has moved from 5 million ton to 1,100 million ton, which is a 200 times more. And which such, we have seen many material in the whole evolution of society, but the kind of growth which plastic is seeing, a phenomenal growth, no other material has seen it. And this, I consider, is because of the solution provider and which will become a better future for the society as well.
Yes, thanks. Because you already partly answered my next question I wanted to ask you. Because one of the things that you mentioned very good point that plastics is a solution provider, not a problem. But there is a very big negative, advertisement about plastics as well, because how they are polluting our seas, our landfills. And so how do you change the mindset of people? People, quite a good number of people, they're always thinking they are using plastic every day, but still they are, saying no, polluting. So what is your view about that?
I mean, if you look at any good thing also has a negative if it is not managed properly. In my views, plastic is a wonderful materials of choice which is available to the society or a human being in the current century and continue to be. However, the perception, because of many other things in last 1 decade or so, has more moved toward a problem creator. And because of that kind of perception, it got a lot of negative impact. But if you trace the origin of this problem, you will see it is a mismanagement by the society. Anything which you use, but if you don't manage it after use, it can be a problem creator. So in my opinion, society globally and also the different part of the world took it that they will take the best out of that, but they will not bother about the negative part of that, and that has allowed the plastic and particularly the packaging material, which is a very thin films and other, to move, thrown at different level, and that has gone into the sea or other, in the dust kind of where we say the microparticles and other generations has taken place, and landfills and other. So in my views, the problem has come, and if you look at the long history of science, whenever scientists are challenged with the problem, they have always come out with a solution. And there is a history behind that for the more than centuries. And this is where all the science has grown in the past, because whenever there. So I see the challenge which has been posed by society to say that it is a problem creator, and the scientists and technologists has already taken as a challenge to solve that problem. And the first step in solving the problem is right management, where the municipal corporations and other, which have in last few years are finding new innovative methods of sorting out the plastics, managing the plastics. Even houses, you are keeping the plastic in different bins and other. So that is a first step toward removing the perception. And second, which scientists and technologists need to provide, that how do we utilize this material effectively for either the next value-added products, or can be converted back to the monomer. So in my opinion, the major success which may come in future, the plastic can be reconverted into oil, and then it can be converted into the monomer. And many development has already been taking place in this area, where it is clearly shown that these material can be converted back to the oil or the monomer, which can be further used and again bring. So circular economy is going to be a very, very important, and those chemistry or catalysis challenges will be overcome in future, and which will be the right solution. Second solution which is emerging out, repurposing the first use materials into some other products which does not require that kind of properties which is required by the first use product. And in addition to that, which I see, there will be some changes in different kind of material use. For example, the polyolefin material, which is non-biodegradable, but in certain application, we will see the trend of either biodegradable or even the photodegradable materials to emerge, because the country where there is a lot of light, I think the photodegradable material will also be the choice. And I believe that chemists will able to provide the synthetic solution for the low cost biodegradable as well as the photodegradable material for the packaging, like packaging industries. So it is only a factor of time, but I am very hopeful in next 1 decade there will be a total solution for moving out, saying it is a problem creator, to appreciate not only as a solution provider, but also clean environment it will provide, which is today is given as a wrong perception. So in my second answer is, it will be a combination of solution provider as well as a clean environment.
And I wanted to ask the question, but you already answered that, particularly what kind of innovation we may expect. But you already mentioned that, if I summarize properly, that you are saying that innovation and functionality, how actually introduce different functionality to improve, let's say, for example, shelf life of food, because how to extend, Then similarly, you also mentioned that another innovation we may expect, that innovation in catalysis to convert, plastics to again monomer or another fuel, to use it. And also another innovation we need is on our behavior, how to actually manage plastics. That is also extremely important, because we all
Corona has
yes.
taught us the discipline. Corona has taught us the discipline in the last 6 months.
We don't want to blame ourselves, but we blame technology and materials, But I fully agree with you. The plastic is a wonder material, and I also, that you mentioned a number of times, that is a so valuable materials, Then we can add so much value to to actually broaden the application, and data is showing and statistics is showing it will be 200-fold within a year, within 100 years. You actually touch base some of the application of plastics, particularly in health sector, and you also mentioned some photodegradable and biodegradable material, because particularly if you think about the in pandemic currently, there was an extensive use of plastic, from mask to grounds to everything, everywhere, every part of but there was another issue also, that how to actually dispose them. So do you think that for health application we can see some functional bio-based material or biodegradable material or photodegradable material? What is your thought about that?
I think infection will stay in the society for a long period of time. That will be the fact. Now, if infection is going to stay for a long period of time in the society, then what are the solutions? I see in last 7-8 months, most of the solutions were done very fast and quick to safeguard and take care of a short-term advantages. But this has, if I see, has given us tremendous opportunity to look at long-term solutions. And now if you look at the long-term solutions, today even the mask, it is a 3-layer or 5 layers, And why we put the 3-layer or 5-layer? Because each layer has a different functions. Now, the challenge is, which we have understood, what is the role of the first layer, what is the role of the second layer, what is the role of the third layer to prevent the infection, but at the same time give a good breathability. I am sure that it is possible to design now synthetic materials which minimize the number of layers. Maybe not 2 instead of 5, and bring those functionality in the backbone of those polymers. And that will really help to bring the much more cost-effective and also long-lasting solution. Another area which is emerging out also in a normal clothing textile. Why only the PPE and the mask? I see there will be antiviral clothing also. I mean, you may have your shirt, also antiviral or antibacterial coming in time, or trousers coming, which will bring a tremendous opportunity in the, polymer opportunities. The other opportunity which I see today, the coating applications. we see, I mean, most of the time we touch the doors, we touch, railing or elevator we go. And today, this infection has forced us to think, can we now move out from normal coating material to the functional coating materials, which can be antiviral, which can be antibacterial and other infections also. So I see, in addition to the clothing sector, which will be booming much more higher, and the growth rate will be much more higher. The coating material will also be growing faster, because all houses, smart cities or houses, even in the car, people would like to have a coating of the materials, which is the antiviral. So that today our challenge is, when we go out, we either wear the gloves or something so that we have a minimum contact. So I think these kind of solution will also come in future. In addition to the health sector, in society, clothing as well as the coating. These are few examples, but I can believe there are many more examples which will, and that will be a real challenge of the synthetic chemist to produce this kind of material in a cost-effective manner. So not only the development, but converting that lab development into commercial production. And then always it is a challenge to processing, because end customer only sees a product. They don't see the whole value chain of how do you synthesize, how do you, store, how do you produce. So in coming years, in my opinion, the processing innovation will also be very critical, and maybe requiring some machinery modifications and optimization of screws and other things, so that a society can get end product the manner in which they want. So whether it is in a fiber form, whether it is an injection molding form, or the blow molding forms. So even tomorrow, your shampoo bottle may be antiviral, material will be antiviral. So anybody touches doesn't affect it over there. But when you make antiviral, there may be some processing challenges, and may also, because you want to retain those properties also, although you are subjecting it to a very high temperature for processing. So I see, from not only for chemistry, for manufacturing technologies, but also the processing of material into the products.
Thank you for your time, and looking forward to have more discussion soon. So thank you.